Destruction without warning. Every year, violent earthquakes kill thousands of people. Despite decades of research and the latest technology, seismologists are still not able to detect the deadly threat in time.
I think it's fair to say that most people in the mainstream of seismology do not believe it's possible to do short-term earthquake prediction today.
But the solution might be under the seismologists' noses.
Many snakes hit their heads against the wall until they were bleeding.
To be prepared for the next quake, school children in China learn rhymes to pay attention to unusual animal behavior. But what's the truth behind these anecdotes and legends?
There is no animal, really, that can detect something that we cannot measure.
Only a few scientists are trying to find out how animals can sense in advance the movement of continental plates. These few are observing phenomena to which seismologists don't usually pay attention.
My work is considered controversial by some.
Could animals help to predict earthquakes in future? Japan is situated on the edges of 4 tectonic plates. About 127 million people live in this geological fracture zone, and earthquakes are part of their daily lives. Often, before an earthquake occurs, curious things are observed by the public. A scientist from Osaka University has been collecting these reports.
My name is Chihiro Yamanaka. I am an associate professor at Osaka University. I live in Kobe, and I experienced the big earthquake in 1995. That moment, we had a lot of strange and unusual phenomena. That triggered me. We should study this phenomenon.
In March 2011, it wasn't only pilot whales that behaved strangely. Professor Yamanaka has collected further observations of unusual animal behavior.
A citizen reported that moles and snakes are frozen to death, probably 1 week before the earthquake.
In Taiwan, too, people witnessed strange animal behavior before earthquakes. Although they're considered untrustworthy by mainstream scientists, geographer Jin Hong-jung still compiles these reports.
Many animals behaved strangely before the violent earthquake in 1999. I have collected and interpreted some reports about the animal behavior. Some animals fled the area. Some rescued themselves by moving to higher ground. Others dug themselves into the earth and disappeared. And fish suddenly jumped out of the water and onto land. Yet even to this day, scientific instruments and observations cannot completely register the occurrence of a quake.
In the Italian Alps, locals also registered unusual animal activity shortly before a quake destroyed their villages in 1976. But what is the underlying reason for such behavior? Helmut Tribuch, professor of physical chemistry, has been studying this question in great detail.
As a scientist, I wasn't convinced that these phenomena are real. I also suspected that it could be a psychological reaction of people after the earthquake. But I decided to investigate. I wanted to learn if this is really a natural phenomenon. And that's why I began to study old documents and to interview eyewitnesses.
Professor Tribuch meets 2 farmers from his village. Back in 1976, they observed how their animals suddenly changed their habits.
The cows didn't want to eat anymore. I couldn't do anything. They jumped always back and forth and didn't want to eat. On the next day, the hay was still untouched.
Some cows even strangled themselves. According to my cousin, they were trying to flee shortly before the earthquake. Because they pulled on their chains, they suffocated. All in all, 8 cows died in the barn.
No one can forget such an experience.
Although the animals are warning us, we're not able to interpret their behavior and realize that an earthquake will happen.
Professor Tribuc has visited many countries to collect reports and information from all over the world.
I have never received any kind of public support for my research, and other scientists have experienced the same. In a way, it is only an amateur research we are doing. But as there are so many people dying during such disasters, it would make sense to at least document these phenomena, because to this day, they are not even documented.
The earthquake region of Nanjing is a center for snake farming. For the Chinese, snakes are a delicacy and an important earthquake sensor.
I've worked with snakes for over 20 years, and I'm familiar with their character and behavior.
In 2005, the snake farmer made a cruel discovery: a deadly mass panic in the snake's enclosure.
Many snakes hit their heads against the wall until they were bleeding. They didn't stop. They wanted to escape and run for their life.
4 days later, the earth trembled in this area. It was a relatively harmless quake with a magnitude of 4.6 on the Richter scale. Did the snakes feel in advance something the scientists missed? After the mass panic in the snake farm, researchers have started to install webcams to observe the reptiles around the clock, and already they've discovered a first pattern in their behavior.
Let's take the huge quake of Sichuan in 2008. Normally, snakes eat every 3 to 4 days, but 10 days before the quake, more than 10,000 snakes suddenly stopped eating. After the quake, they surfaced in large groups and moved in circles. At this point, we knew that there will be heavy aftershocks. The next day, we had one with a magnitude of 6.4.
But the authorities never sent out a warning to the people in Sichuan. More than 5 million buildings are destroyed, 70,000 people die under the rubble. Why didn't the behavior of the snakes lead to a widespread evacuation?
We are still not able to make a precise prediction when, where exactly, and how violent an earthquake will be when our snakes show unusual behavior. It is still a long way to go. But the fact that snakes warn us a few days in advance is really useful. There is nothing which is comparable to it.
But what exactly alerted the snakes? A scientist in Germany studies the sensory organs of the reptiles.
My name is Guido Westhoff. I am a zoologist and manager of the tropical aquarium at Hagenbeck Zoo in Hamburg. Snakes don't have outer ears, no eardrum, no ossicle like humans have, but they still have a very well-developed inner ear. For a long time, scientists didn't understand this until they noticed a connection between the inner ear and the lower jaw. This means snakes listen to the ground. And snakes would be stupid if they didn't do that. When I lie on the ground all day long without a possibility to have a perspective from above, how else shall I get information if not from the ground? On the ground, I get information from which direction someone is coming. Does it have 2 or 4 legs? How heavy? How fast is it? Today, we know that snakes get all this information from the vibrations in the ground, and this gives them a clear advantage. The inner ear of a snake sits in the skull, just where we have it too. This is a skull of a reticulated python, and here at the back is situated the inner ear.
Instead of sound waves, snakes are able to record vibrations with their inner ear. Those oscillations are first registered by the underjaw and are then passed on by several ossicles to the inner ear. The time difference between the two lower jaw bones picking up a vibration enables the animal to locate the signal source. This sense of vibration is so sensitive that snakes can detect the slightest tremors, including those which happen before an earthquake. A Chinese propaganda film even claims that scientists were once able to predict an earthquake with the help of snakes sensing the danger. Haichong in February 1975. Hibernating snakes suddenly left their holes in the middle of winter. According to the film, they painfully froze to death on the blanket of snow. Despite the cold, fish were swimming to the surface. One could catch them by hand without any difficulties. In addition, slight foreshocks and sudden changes of groundwater level concerned the authorities. The residents were told to watch out. Because of all these different precursors, the authorities arranged the evacuation of the city. The army and rescue forces were mobilized and prepared emergency accommodation. Eventually, 1 million people were moved to a safe place. A short time later, an earthquake with a magnitude of 7.3 destroyed large parts of the city. It's estimated that the massive evacuation effort saved 150,000 lives. In the capital city of Taiwan, seismologists prefer to trust modern instruments. All seismic data is collected by the Central Weather Bureau.
Taiwan is situated on the border of the Eurasian Plate and the Philippine Ocean Plate. In addition, there is the Pacific earthquake belt around us. This is why earthquake shocks occur frequently here.
Tectonic plates move on average 2 centimeters per year. But in Taiwan, the heavy sea plate squeezes beneath the lighter continental plate by a whopping 8 centimeters every year. In the process, the plates may jam and the pressure rises. If suddenly the tension discharges, an earthquake will occur. Like on September the 21st, 1999. The epicenter was in the heart of the Taiwanese island. It was the biggest disaster in Taiwan since the Second World War and left 2,500 people dead. Despite these devastating figures, scientists in Taipei are proud of their level of earthquake warning.
We routinely analyze seismic information together with geophysical, GPS, ionospheric, geomagnetic, and groundwater data. Our early warning system can be considered mature. During the big earthquake in 1999, we were able to send out a warning message within 102 seconds.
An earthquake warning of about 2 minutes seems to be the maximum which is technically possible worldwide. But such a short warning works only if the people are prepared for disaster. In the Chinese city of Nanjing, school children learn how to react to an earthquake warning. They regularly practice an emergency evacuation. In order to keep loss of life to a minimum for the next quake, America relies mainly on earthquake-proof architecture and engineering. In addition, the United States Geological Survey spends $30 million each year to understand better the forces of nature.
My name is David Oppenheimer. I'm a seismologist and I work for the U.S. Geological Survey. There are 13 seismic networks in California, and we all connect up using the internet. Most of our stations are in the urban areas today because we are trying to record ground motions very close to structures that might be damaged by earthquakes.
Next door, geologist David Lochner wants to study the mechanism of an earthquake with two pieces of rock.
Now we're going to make a laboratory version of an earthquake. And to do that, we need a fault surface. So here is the fault. And we'll put the sample together, and in the pressure vessel, we will squeeze it and force the fault to slide like this and cause an earthquake. So first we have to put this in the jacket and assemble the sample to put in the pressure vessel.
Will these small rock samples provide any useful information about the behavior of continent-sized tectonic plates?
I personally am not sure if we will ever predict earthquakes in a way that will be useful for society. And we know mostly where faults are, and we know the rate of activity on them from year to decade to century. So we can identify places that are at risk, but knowing the very short-term day to month type forecasting or prediction, that is a much more difficult problem today.
We have tried very hard. We have run specific experiments, but there's nothing that we see in the data that's reproducible that tells us that we can use that data to predict earthquakes, whether it's seismology or strain data or creeping faults, gas emissions, or magnetometer data. None of it has been very reliable.
In October 1989, during the World Series of Baseball, geologists are rocked by surprise as they witness one of the heaviest quakes for decades. The region around San Francisco shook for almost 15 seconds. Because of the sports coverage, helicopters were in the air, able to record dramatic images.
25238, we have a major injury accident, Cypress and West.
Not everyone was surprised. One person expected the disaster. Jim Birkeland, a former county geologist, had developed his own method for predicting earthquakes.
In 1989, I was well aware of a number of factors that preceded earthquakes. We were having the highest tidal force in 3 years on the 14th of October. And at the same time, we had a record number of missing dogs and cats, as shown in the lost and found section of the local paper. Before the '89 quake, there were, instead of 4 or 5 missing cats, it went up to 28, which is the all-time record. And the dogs, missing dogs, went to one of the all-time records of 58. And so just 4 days before, there were at least 10 clues that a big quake was coming, and so I called the Gilroy Dispatch to predict it.
At least 3 or 4 trucks coming.
But no one acted on Jim Birkeland's warning. 63 people died under the falling debris. The prediction in a local newspaper also had drastic consequences for Birkeland.
I was suspended, and it wasn't just a few days, it was 2.5 months. You know, everything was really upset for having correctly predicted the World Series quake. And finally, in early January, I was told I could return to work if I would promise, cross my heart, I won't predict any more quakes on county time.
3 weeks before the quake, a different set of odd data was recorded near the epicenter. This time, there were no animals behaving strangely, but an instrument measuring the Earth's magnetic field. Anthony Fraser Smith, working at Stanford University, was puzzled about the data he was collecting.
We were at Corralitos making measurements of ultra-low frequency signals from space, and we're very used to how they looked. But all of a sudden, we began getting signals that were totally unusual and certainly bore no relationship whatsoever to the signals we had been measuring from space. These are some of the original data we recorded prior to the Loma Prieta earthquake that occurred in October 1989. Right here, about the 5th of October, we had this big increase. It's about 30 times the normal level that you see everywhere on every one of these charts. And the signals remained high up until this point. And then when the earthquake occurred, we lost electric power to our system, which is why there's this big drop-off. But just prior to the earthquake, in an interval of about 3 hours, there was another big increase up to a level which is about 100 times the level at all other times. I think a large number of scientists are somewhat convinced that there are magnetic fields preceding earthquakes. I actually do believe that they do exist, and if we make more measurements, it will help verify that that's the case.
I'm Joseph Kirschvink. I'm a professor of geobiology at the California Institute of Technology. I was intrigued by the fact that these honeybee swarming behaviors had been reported prior to major earthquakes in several parts of the globe, in different cultures, different backgrounds. But what is actually happening there? Each honeybee will drink a small amount of the honey, usually 60 microliters or so. And it basically loads its body up to the point where it can just barely fly with honey. By swarming, they would go and eat as much of the honey as they could, saving it for making the hive after the earthquake. So that's a very clear case where a behavior could minimize the harm done by an earthquake.
Kirschvink wants to prove that bees can notice changes in the magnetic field. This could explain why they seem to know beforehand that a quake will happen.
Many animals have a magnetic sensory system. So if there were electromagnetic changes before earthquakes, it's entirely possible that they may have learned through natural selection to escape or to do something that would help them escape from the effects of an earthquake. That's entirely plausible.
With a 50% sugar solution, he wants to attract the bees to the magnet.
Just a little drop in the middle.
As none of the bees would find the sugar solution on their own, Joseph Kirschvink gives some assistance.
She's now drinking the sugar water, and once she fills up, she's going to wander around and then fly in a small area pattern to memorize where it is, and then she'll run up and go back to the hive. And hopefully in 3 or 4 minutes she'll be back for more. It's very addictive, 50% sucrose.
Kirschvink is right. After a short time, the bee comes back.
And you will be a happy bee.
What happened when the bee flew to the probe with a magnetic field? The bee uses the Earth's magnetic field like a compass. In its abdomen, there are tiny minerals which are magnetic. These minerals always align parallel to the magnetic field lines. When the magnetic field changes, nerves are stimulated and the information is transferred to the brain.
Now we've got the magnet with the final strong sugar, and she's going to be coming back any time now. Once she fills up, we'll do the trick on her. We'll take off the strong sugar, put the magnet under one, and then there'll be water on the two targets. And so she'll go down, think the one with the magnet is the one, probably, she may be a little confused by having two targets. But what we've seen in past experiences, that when she finds the water, she'll get upset, she'll run around and land again and try the other target. But she'll make more attempts at the target with the magnet because she's been trained to associate the magnet with good sugar. And that tells us the animal can detect the magnetic field.
The experiment shows that bees can detect changes in the magnetic field and use this information to prepare for an earthquake. But for seismologists, the Earth's magnetic field plays only a minor role for the prediction of earthquakes.
My colleagues here at Caltech and the U.S. Geological Survey have about 300 seismic stations in Southern California alone. It wouldn't hurt to put a few magnetometers out there as well.
There is, however, one geophysicist who uses magnetometers. He measures ultra-low frequency waves from space to determine changes in the Earth's magnetic field.
I'm Simon Klemperer. I'm professor of geophysics at Stanford University. We're trying to find out the relationship between earthquake activity and the ULF waves. ULF waves are pervasive in the atmosphere all the time. They're created by the solar wind impinging on the atmosphere, and then they radiate through the atmosphere and propagate into the Earth. This is our vertical magnetometer. It's about 1 meter long, set vertically down in the Earth. It consists of a magnetic core and then thousands of turns of electrical wire around it. When the ULF waves impinge on the Earth and change the magnetic field by a part in 100,000, it generates a tiny voltage on those wires that we record on our digitizers and signal analyzers down there. If we see any anomalous signals, we'll look carefully at the amplitudes and the timing of these signals and try and develop geological theories about what might have happened in the moments before the earthquake ruptured and use that to understand the physics of the earthquake process. Eventually, if we build up that understanding of the physics, then we may have a tool that could lead to the predictability of earthquakes. We have this network of 5 stations in the Bay Area, but we only have about a 2/3 or 3/4 chance of a very big earthquake in the next 30 years. That means during my professional career, we will probably record an earthquake, a big earthquake, just once on my network.
Historically, violent and destructive earthquakes have been witnessed by almost every generation in Japan. A religious pilgrimage site has been dedicated to an animal which has a special role in the occurrence of these earthquakes.
My name is Osamu Kanayama, and I am the priest of the Omura Shrine. The catfish is very important for us. It is holy to us, like a god.
The Japanese pray to be spared from a deadly earthquake. An old legend tells the story of the catfish and its power to cause earthquakes. Once a giant catfish laid on the ocean floor, with the Japanese island resting on its back. The god Kashima restrained the giant fish with a stone. But when Kashima was distracted, the catfish moved and the earth of Japan trembled. Catfish are well known for their sensitive reactions before earthquakes. Once this fish was part of a scientific research project until its owner died. For the widow, Yoshiko Ikeya, the fish is something very special.
On February 23, 2011, the catfish started to behave strangely. It had stopped eating and seemed almost dead. I thought it was dying because it floated vertically in the water and its head was just under the water's surface. This was very unusual.
Her husband, Motoyi Ikeya, had investigated why catfish react in such an intense manner before an earthquake.
This is a picture of my husband and the setup of his experiment. A television crew took it. He looks so happy because the catfish reacted very well. His colleagues were skeptical and said, if you succeed, you can just save perhaps 10 of the thousands of people. My husband answered, the number of people isn't important. Saving 10 people means my research is worth it. That's what he always said.
Chihiro Yamanaka has recreated the experiment in his laboratory. Once he was a student of Motoyi Ikeya.
So now I put an electric field between the electrodes and a catfish inside of the aquarium. The voltage between the electrodes will be 0.5 volts. Under usual conditions, a battery has 1.5 volts. The voltage is quite low, and the duration of the pulse is about 100 milliseconds, a very short time. And I put the electric pulse now, like this, and the catfish can feel the electric change right now. I put my finger inside and try it again. Yes, the catfish can feel the electric field, but I never feel anything.
Special sensor cells all over the body enable the catfish to register the electric field in the water. The catfish uses this unique sense mainly to locate prey. The respiratory muscles from other fish generate tiny electrical impulses. These signals are picked up by the various sensors all over the catfish's body. The small time difference enables the catfish to locate the prey precisely. For the Japanese, dogs also play an important role in their everyday life. About 13 million live on the island state. Some of these pets, like the Kinkori family's dog, have special skills.
Yeah,
6 years ago, we got our dog and immediately noticed that she has something special. She always shows the same behavior before an earthquake.
She lies on her back and pedals with her legs.
Sometimes it happens at the day of the earthquake or before.
5 or 6 days, sometimes even a week in advance.
But it happens regularly before heavy earthquakes.
My name is Mitsuaki Ota, and I'm a professor of veterinary medicine. 12 years ago, I started to research the relationship between human beings and animals at Azabu University.
The Kinkori family's dog is very ill and no longer reacts before earthquakes.
I have worked with dogs and cats for a very long time to verify whether they react to electromagnetic waves. Recently, we've developed an instrument which generates electromagnetic fields so we can now conduct specific experiments.
Beneath the floor is a metal ring which generates electromagnetic fields. Here, they are the strongest. It's about 30 volts per meter. But the head of dogs is usually on a higher level. Here, we measure about 20 volts per meter.
Now the experiment can start. Ota asks his assistants to take one dog after another and lead them through the electromagnetic field. He randomly switches the field on and off to ensure that no other stimulus affects the dog and distorts the result. Will at least one dog react to the electromagnetic field? The search for an earthquake-sensitive dog is unsuccessful today. When finally the office cat passes through the setup without any reaction, Ota stops his search for the day. He's not surprised about today's results.
In our experience, only 12 out of 500 dogs react to electromagnetic waves.
So only exceptional dogs are able to sense changes in the electromagnetic field. But Mitsuaki Ota does not give up his search. He has grand plans for man's best friend. South of San Francisco is the workshop of a pioneer in earthquake research.
My name is Friedemann Freund. My work is considered controversial by some because it's so new. We have a piece of rock here that comes from deep in the Earth's crust, and we have attached a copper electrode to this far end. And in this area here, we have another copper electrode hidden under this piston, and we apply pressure on this portion of the rock. Then, when we connect this electrode to this electrode through an ampere meter, a current starts to flow through the rock, which we can measure. And this was never known and recognized before.
The press simulates the forces of tectonic plates before an earthquake. The experiment assumes that also in nature, electric streams flow through the Earth's crust before an earthquake.
The presence of an electric current has enormous consequences for understanding a large number of processes, including what animals might feel when the Earth becomes stressed prior to an earthquake.
Is it the actual electric current that the animals sense? Or are they provoked by electrically charged atoms, so-called ions, that are released to the air by the underground current? Scientists now want to use lab rats to investigate how animals react to ions in the air. The experiment is still in the planning phase.
My name is Professor Dan Hawley in the Department of Biological Sciences at San Jose State University. We've designed a laboratory experiment which will help us answer that question. What is the mechanism? You know, what are the sensors? So how are they sensing the change in the ionization? Is it something olfactory? Is it something gustatory relative to taste? Is it irritation of the nasal passages? Whatever the sensor is, does it change animal hormonal levels, for instance? Does it produce a stress response or an alarm reaction? And maybe it's the alarm reaction that's producing the change in producing the bizarre behavior. So Friedemann, we've designed an experiment to help understand your theory about the compression of the rocks deep in the crust. It's a habitat choice selection experiment. We have a habitat A, habitat B connected by a tube. And what we will do is we will take this ion generator, and this will produce either positive ions or negative ions, so we can study the effects of each. And this will actually go on to one of the habitats at a time. At the end of 14 days, we'll move this to the other side, so it's a crossover design, which then controls for the effect of the habitat itself.
Yes.
Large amounts of positive ions could affect the body and trigger a specific behavior of the rats. In several experiments, the researcher wants to investigate whether a higher ion concentration in one chamber will cause confusion, headache, nervousness, and elevated pain sensitivity. The rat should then have enough reason to switch the chamber.
This experiment is really extremely well designed. It follows all the strict procedures that you have to apply when you do a controlled experiment. And by offering animals the choice between two identical habitats and change the conditions under which, I think is exactly what we need in order to make progress in this area of animal behavior. Because we cannot ask them, they cannot tell us. They will tell us through their behavior what they feel.
On April the 6th, 2009, L'Aquila in central Italy was hit by a devastating earthquake. 308 people died. Even today, parts of the historic center are closed for safety reasons. Lago di San Rufino is located 75 kilometers north of L'Aquila. Every year between March and June, common toads populate the lake. It's mating season.
I'm Rachel Grant. I'm a scientist studying amphibians at the Open University.
For years, the English biologist has been visiting the lake to observe the mating habits of the toads, so she was able to collect plenty of data about their behavior.
We've studied these toads since 2006, and their behavior is quite predictable.
At night, the animals are most active. But 1 week before the earthquake, everything was different.
In 2009, there was a dramatic change in their behavior. When the full moon was approaching, the number of toads seen declined from 96 one night to 2 the following evening. And for 5 days, there were no toads.
A mystery. Did the disappearance of the toads have something to do with the earthquake? A first clue comes from an independent researcher and inventor.
My name is Giampaolo Giuliani. The last 20 years, I have worked for the Laboratory of Nuclear Physics in Gran Sasso. The Earth was shaking for 28 seconds. 28 seconds, which seemed to be endless. I developed an instrument, the Gamma Tester. This device can detect radon gas. Radon is a radioactive gas which rises naturally from the ground. According to my research, we can say that there is a heavy increase of radon gas only before an earthquake, never during and never after an earthquake.
Giuliani had set up 4 instruments. 48 hours before the earthquake, the values of the radon concentration suddenly tripled. This was a clear warning signal for Giuliani.
Between April 4th and 5th, we registered a steep increase of radon. The data we collected at the time, we had never seen before.
We listed a lot of possible causes that may have made the toads leave. For example, we looked at gases which are escaping from the ground, such as radon. We ruled out most of these on the basis of the time period, because the toads left 5 days before, so we knew that radon gas was affected after that period, so we didn't think they were the causes of it. So we finally came up with a possible cause, which we think is the release of charged particles causing oxidation in water chemistry.
Toads are very sensitive to chemical changes in the water. For amphibians, oxidation in the water could even become life-threatening. Special receptors on the skin sense the changes in the water and send out warning signals to the brain. The toad flees. Whether charged particles from the ground actually cause an oxidation in the water has only been a theory until now. Friedemann Freund integrates Rachel's assumptions in his experiments.
We set up an experiment in which we specifically were looking for the formation of hydrogen peroxide while we were stressing a rock at this end. And here we had a pool of water, and we were measuring And of course, we were closing the circuit so that the current was flowing. And we were able to show that when the charge carriers travel through the rock, enter the water becomes stoichiometrically oxidized to hydrogen peroxide.
Friedemann Freund's experiment gives a plausible explanation for the disappearance of the toads. Shortly after the earthquake, the amphibians started returning to the lake. 3 days later, half of the toads were back in the water. For Rachel Grant, it's a clear sign that the exodus of toads and the earthquake are related. In the future, the biologist will take water samples regularly. She needs to wait for the next quake, but then she will be able to determine whether her theory is right. Once it's verified to what precisely the toads had reacted, earthquake researchers can develop the corresponding detectors. Some Taiwanese earthquake scientists have been looking not at the ground, but into space. The Ionospheric Radioscience Laboratory of the National Central University leads the world in observing the effect of charged particles.
In 1990, we experienced many quakes, and before they occurred, we always recorded a high density of electrons in the ionosphere. I was interested in their relationship and started to study it. In our research project, Formosat 3, we work with 6 monitoring satellites. They can record the ionosphere 3-dimensionally and analyze it.
When in 1999 Taiwan was hit by the big earthquake, space researchers were already recording unique data of the ionosphere. Although they were not able to give a concrete warning to the public, they discovered a link between their data and the earthquake. A few days beforehand, the satellites had registered a significant decrease in the number of electrons in the ionosphere.
In the afternoons, 4, 3, and 1 day before the earthquake, the density of electrons suddenly fell by about 50% below the usual figures. After the earthquake, the instruments returned back to the normal values.
Because of the enormous pressure in the ground, positively charged particles emerge in the rock and travel to the Earth's surface. The positive charge of the Earth's surface is transferred to the air in the form of positive ions. This layer of ions rises 300 kilometers to the ionosphere, where it changes the ion density.
Because of the satellites and the accidental earth shocks, we were able to prove physically the precursors of the earthquakes in the ionosphere.
Instead of satellite technology, Mitsuaki Ota in Yokohama still pins his hopes on Japan's most popular pet. He has developed a system to train the dogs so that they can warn their owners in case they sense the coming of an earthquake.
When dogs feel the electromagnetic field, they often bark or scratch on the floor, but people cannot interpret this behavior correctly because it is nothing unusual. We have developed this system where the animal can provide a clear sign to the human owner. When the dog feels the changes in the electromagnetic field, it pulls a rope and gets a reward. A lamp indicates to the owner that the system was activated. We have trained the dogs for that.
Dogs as an early warning system? This vision from Japan appears adventurous, but several animals actually could predict a fatal quake and save human lives. Earthquake prediction with the help of animals seems to be only a question of time.
I am convinced that animals are much more sensitive to natural processes because they live closer to nature.
If there's even a tiny chance that what we know about animals can save someone's life, then I think this deserves to be funded.
We shouldn't have to rely on animal behavior to tell us when an earthquake is coming. If the animals are perceiving something, we should be able to measure it in the laboratory or in field sensors at a level better than they could do. We're better than Mother Nature for some things.
Earthquake forecasting would certainly be possible, and I would dare to say that if we get a little bit of funding, a little bit means a few $1 million per year, it could be done in 5 years.